So let's do this one. This is a first approach or the first example that we're going to do regarding centroids. And I think it's a pretty easy one, but nonetheless, let's just see about it, okay? The idea behind it is to get, this is what they are asking us to get. The idea is to get where do you think the center of gravity, it's not a center of gravity per se, because when you talk about areas, well, they are not bodies, they are not volumes. Therefore, you cannot say, strictly speaking, that you're going to talk about a center of gravity. Nonetheless, is where would you put a stick to this board, for example, and this thing will remain in equilibrium. This thing will not fall to one side or the other. That's the idea behind a centroid. So let's just try it. I get it. This is what they're asking you. Please give me the coordinates x hat and y hat. So where there it's going to be located the center of the area of this blue area. Okay, so the white area is something that has been cut out from the blue area. Now, the first thing that you need to do in this type of problems is to locate the axis or the origin, I would say. So hopefully you find out that here over there, that's the origin, because you have the x-axis over here, and the y-axis going up in the vertical position, okay, in the vertical direction. Okay, so you have this is where the origin is. And why would you need the origin? Well, because it's your reference point in order to locate this x hat and y hat. Okay, now I have done this. The second part is to find out how many areas do you have here, and try to do this as easy as possible. Let's just find out how many areas we are dealing with. Okay, so perhaps you know about the semicircle. So there is a blue big semicircle that is go from, let me just use this. So let's just use it, okay? So this is the blue, semicircle. Well, you know, kind of, right? So I'm just going to do all this. So that's my first area, okay? So I'm gonna call this area 1. Okay, so this is area 1 over there. Fine. Hey, what about the big, I mean, it wasn't big, right? The triangle, the white triangle in the middle. What about it? Oh, you're right. So there's a second area that has been cut out from the first area. So, okay, so we're gonna do it with another color. So the highlighter, and let's just do this one. No, maybe this one. Okay, now from here to there, I don't know how this thing will look, but it doesn't really matter. So you have 2 areas, okay? So I have one triangle there, and I'm gonna call this, this is section 2 or area 2 or whatever name you wanna put it. So that's what you're dealing with. So you have 2 areas. You could have more areas if you want to divide further, but I won't suggest you to do that because it's gonna be a long problem, okay? So you can actually divide, let me just use another color. You can actually divide, let me choose this one to be a fancy one. Divide the big triangle into 2 triangles. So this triangle can be divided further into 2 triangles. This one first and the other one later. So you could actually have 1, 2, and 3 areas, okay? But I won't suggest you to do it because it's a little bit harder, okay? Well, let me just erase that stuff over there. So now we're dealing with 2 areas, just 2 areas. Now, this is the deal with this. Now that you have 2 areas, you need to build a table. So I'm gonna build a table for the first area and for the second area, okay? So you know a table. This method is called the composite areas because you are trying to average both areas. What do you mean by average? Well, it's just like a method in order to get the average of something, the average of a coordinate. And that thing will give you this coordinate of the centroid. Well, this is just blah, 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 okay? But now let's just go and look into the method. First of all, get the areas of all of them. Oh, okay, so I have numerical values. you can do it. So let's start with the first area. Now, for this body, it's not a body, it's an area. So for this one over here, you have 5 inches. The area of this stuff could be a semicircle. It's just pi times r squared divided by 2, okay? So if I'm doing things right, the area of section 1 is actually 25 pi divided by 2, okay? Why 25? Well, because it's 5 squared and you need to divide it by 2, so you get it, okay? This is what you have over here. This is 25 pi divided by 2. Okay, so inches squared. Good. Now, what about 2? Well, let's just go with 2. You're right. Let's just go and see about 2. 2 is a triangle like this one. I have the base and I have the height. This thing is 6 and this thing is 4 inches. Okay, yeah. So what about it? Well, so the area of 2 is gonna be base times height divided by 2. Therefore, this is a 12 inches squared. Okay, so you will put 12 here, but then comes a minus. Why? Well, because at first it was like that. So I'm gonna just like that. It was a wide area, and the wide area in this book, they are trying to tell you that it's a hole, okay? It's a triangular hole within the semicircle. So it's just like an area, but negative. I know there are no negative areas, but it's just like a lack of area for the whole semicircle. That's the way to treat these problems, okay? So whenever you see a hole over there, try to put a negative sign there, because otherwise the problem will not be solved. Fine, that's the first column. These columns that I'm gonna put, they are not in order, but this is the order that I usually prefer, okay? So what about it? Well, now you need to locate for each one of those areas the coordinate part of its own centroid. Own centroid, yeah, this semicircle has a centroid of its own. This triangle has a centroid of its own. Let's just get the x part. So I'm gonna erase over here. So I'm gonna, all the stuff, we already seen it. So there. Now for the semicircle, for the one part. Now from here, it says, I cannot go to the left because it doesn't make any sense, right? I'm working here at my right. Now, what I'm going to do is to go over here, but how much? That's the basic question. Where do you think the centroid for this semicircle is going to be located? Well, it's going to be located at my, forget about the hole, okay? Forget about the triangular hole. You are actually working these two things like independent, like if they were totally independent areas, and they actually are independent areas. That's how you solve these problems. So imagine that everything is blue, okay? Everything is blue over here, and you need to find out, where this C1 for the section 1 is located. So it's right here at the center of this semicircle. Well, there's a formula. That says, okay, so if you want to go there, you need to do 4r divided by 3 pi. That's a formula that will get you in the x direction, where you will find the C1. Okay, so now let's just you just need to put, so x1, it's gonna be over there. So 4 times 5 divided by 3 pi. Okay, so that's what you get over there. Now let's just put it. This is actually 20 divided by 3 and pi. Good. Is that it? Well, that's it for the semicircle. Let's just go ahead and do it for the triangle. Now for the triangle we have over here. Now, if you remember, for the triangle, you will need to move the x part, okay? So somewhere here. Well, I actually don't know if it's here or maybe here. I actually don't know, okay? But it doesn't really matter. What matters is that you have information in order to get that point. So let me just do it with another. So around there, maybe. How do you know it's for certain? Well, when I'm using a formula, I will know for certain where the C2 it's gonna be. So For the x part, I cannot go to my left because there's no triangle to the left. So I need to go into the area, the white area of the triangle, into this direction. But how much? Well, there's a formula that will tell you that you need to walk from the base. Now, from the base, you need to walk from here to there one third of this distance over here. Yep, yeah. So it's gonna be, so the x2, it's gonna be one third of the total height, which is 4. Therefore, x2 equals to 4 divided by 3. So you're gonna put 4 divided by 3, okay? Well, okay, let me just do it with the one that I was working with. Okay, so, oops, come on, yeah, thank you. Now let's just go and 4 divided by 3, got it. What else? Well, let's just see about the y part. Oh, there is also a y part, yeah, sure. There is also a y1 for this fella, and there is a y2 for this fella over there. Okay, so how much is this going to be? Well, I don't know if you see it, but the x axis is over here, the y axis is over there. Okay, so what? Well, how much you need to move up in order to find the centroid, or how much you need to move down? Now it's basically a question of where this it's going to be a plus going up or a minus because you're going down. How much, where do you think you will find the centroid? And I don't know if you see this, but this is actually placed symmetrically. This semicircle, it's being cut in half by this x-axis over here, okay? So it's been cut in half. You have the same amount of area up that the same amount of area here down. Therefore, with some sense or some logical intuition or whatever you want to call it, you can find out that I don't need to walk a thing up nor down in order to find where this centroid here is. Hey, why not? Because everything is so symmetric. If you move up, it doesn't make any sense. It's not that you have more area here up than here down, okay? So it's proportionally distributed in the positive direction of y and in the negative direction of y. You don't have more area back down or more area here up in this direction. Therefore, this thing is 0. You will find the center right at axis x. If you will find it over here, then you need to walk up a little bit. If you will find it over here, then you need to walk something down, but not in this case. And surprise, for the triangle, the same thing. How? Why? Well, you just walk from here to there, right? Why would you need to walk up? Because there's no more triangle up than triangle down, right? So it's right in the middle. Also, the x-axis is cutting in half this big triangle. Okay, so therefore the C2 is going to be located, I don't know where, but it's going to be located right in the x-axis. Nothing at y up and nothing at y down. Okay, well, that's the thing with this. Now that you got all this information, you need to get this. But now it's pretty simple because you already know something. YA. Why are you doing this? Well, this is a method. This is a way to find this stuff. So surprise, surprise, this thing is going to be 0. Okay, yeah, you're right, because you are just multiplying the y, which is a coordinate for y for each one of those areas, okay, times the area of each one of those areas. Okay, so now you have 0 and you have 0. The area is not 0, but the y is 0. Now let's just go with something that we need to put in the right way. So it's just this times this, okay? So it's a times x, so you will have out of this, you will have, there's something wrong there. Oh my God. I'm gonna leave it like that, okay? So you can find out my mistakes. I can make another video and be as perfect as I can, but nobody, I'm not perfect. And this is why I need to do this, so I can know where I'm doing mistakes. But this is the formula is telling me that the pi needs to be in the denominator, okay? So the area has a pi in the numerator, but not for finding the centroid for a semicircle, okay? Okay, so this guy was pi down. Okay, so I just realized that now. I don't know, like 10 minutes within the video. And then if you do this, this thing is gonna be 10. Okay, so it's just 250. Okay, 250 because it's a 10 divided by 3. And that's it, because the pi and the pi would just cancel out. Okay, that's what you have over there. And I think I'm right. I think I'm right. Let me just review if I'm not doing another mistake, because I usually do. That's the whole point of teaching, to realize where your mistakes are. So if this is correct, what I'm going to do is just put it here and there. So I'm just going to, yep, to make myself some room. So this thing is 250 divided by 3, and no pi whatsoever, because the pi with the pi just cancels out. And this is something that you need to get in order to solve the problem. Now, what about this stuff? Well, about this guy, what I will have here is just, maybe I can figure that out, and this thing will be, let's just see, this is minus, this is my way to do this, okay? So don't worry. I know that you have your calculator, but I never use calculator. So, well, almost never. So what I have over here is just 4 times 3. Therefore, this 3 will cancel out with this 3, and you have 4 squared, which is a minus 16. The minus prevails, okay? Why prevails? Because you have a minus times a plus, therefore it's a minus over there. Now that you have solved these things over here, you need to add rows. So I'm gonna add row 1 with row 2 for this fella over here. That is, you need to get this stuff over here, and also you need to get this stuff over there. This one is gonna be pretty simple. I already ended. Now, but this one is gonna give me something else, okay? So what I'm going to put over here is that XA equals to, I need to add this row plus this row, and this thing is just, I don't know. I'm just going to put the same stuff, okay? Well, that's what I have over there. You need to add this column, and you need to add the rows of this column, okay? That's how you solve this stuff so far. But you don't know what else to use, okay? So now I'm gonna tell you. C is a centroid of the whole figure, okay? It's gonna be X total, comma, Y total, okay? So this is another way to differentiate these X1s that I have put over here. You know, I put a 1 Roman over here and a 2 Roman over here. Okay, so this is my distinction between these individual parts with the whole part. This is the global, or the global shape or area. And I need to get those guys. Okay, so do you have a formula? Yes, I have a formula, and it's like an average. Maybe you realize that it's this. You get the X part, XA, to get the X total, divided by all the areas. Oh, there are just 2 areas. Okay, fine, so just use 2 areas. And you will get it with something. Now, let's just go for Y total. So Y total is gonna be adding all the Y's times A, okay, divided by sum of all the areas. Now, we just missed that, but we're gonna do it so here. So you need to get also this guy over here. So adding all the areas will give me, well, I don't know, 25 divided by 2 pi is up, minus 12, okay? So it's just putting, you just need to put numbers over there, and you will put, for example, 250 divided by 3 minus 16, and everything is gonna be divided by 25 pi divided by 2 minus 12. So in this case, sorry, I betrayed myself by using calculator before, and I have this number. So X total is gonna be located at 2.47 inches. Okay, that's where the coordinate for the X part is gonna be located for both of these areas, both the semicircle and the triangular, both the area and the whole, okay? So this is where this guy will live. xt is going to be 2.47 inches. Now let's just go to do this guy. This one is pretty simple because if you add all these rows for this column, you will get a 0 over there, and it doesn't really matter what you have down here, which is again 25 pi divided by 2 minus 12. So you will get a 0. Therefore, the y total part, the y total, that is the vertical coordinate for the centroid, it's going to be located at 0 inches. So I don't know if you see it, but your global centroid for both of these areas, it's going to be located right in the x-axis. So let me just try to illustrate you that. This is not important right now. We already solved the whole deal. So now, let's just put it over there. So now this guy is 4, this guy is 3. I don't know, I don't need that. So around here lies C. And C is X total, Y total. So this is where this C is living. How did you got it? Well, I got it by doing an average. An average of what? Well, I don't know if you see it, but this is actually an average. You are getting some information for the coordinates, some information for each one of the areas, and you will add them up, boom, 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 boom. If some of the areas are bigger, you will find that out here that it has more weight, okay? It's like a weighted average divided by the sum of areas here. Same thing for the y part. This is what you need to do for the y part. Therefore, you're actually doing an average of areas in order to get where the location of the average of those areas is going to be located. It's one way to see it, okay? It's not a proper description. I'm not interested right now in proper descriptions or in a proper definition for this centroid. I just want you to know how to solve problems, okay? So this is for today, okay? Oh, take a look at this one and try to solve it. You will see that this is not that problematic. You just need to use a table, okay, and be done with it, okay? Just use a table, be methodic about it, see what I have done, and comment on the comment section if you have something to say or tell me if I'm doing something wrong or whatever you want to say. See you guys.